All right, let's get started on the second learning objective. So this is the objective that you will be taking on day 2 of the test. So the first day you're going to be doing the graphing, and then you'll get started on learning objective 3, which is the review of solving. And then the second day you take the test, you will finish the review of solving and then also do the solving for um, systems of equations. So let's start with number 5. So on these problems, I have stuck with one method. I'm going to be doing the linear combination, so either getting the x's or the y's to be the same amount. So let's start with the first one. So on number 5, when I look at my x's and the y's, the first number that the x's are going to have in common are going to be 15. And then on the x, y's, the first number they have in common will be 6. And so I'm going to go ahead and go with the 6 because one of the y's is negative and the other y is positive. So I'm going to work to get both of those to become a 6. So on my top equation, I'll be taking everything times 3 because 3 times 2 gets me the negative 6y that I want. So I'm going to go ahead and do that. So there's 3x times 3. Here's negative 2y times 3. And then 10 times 3. And then on the second equation, I'm going to take everything times 2. And so 5x becomes 10x, 3y becomes 6y, and negative 15 becomes negative 30. So I'm going to go ahead and add them up. And when I add everything up, the y's go away. The regular numbers add up to 0. Don't stop the problem yet, because when I add up the x's, I get 19x equals 0. And then when I divide by 19 to get x by itself, x is 0. So you do get a solution here. It's not no solution or infinite solutions. So my x coordinate is 0. And now what I'm going to do is take the fact that x is 0, and I'm going to go to one of the equations at the top, and I'm just going to use this one. And what I'm going to do is make x become 0. So 3x minus 2y equals 10. I'm going to take the fact that x is 0 and put it into my first term, which turns that term into 0. And that just becomes negative 2y equals 10. So when I'm done by dividing by negative 2, I get my y to be negative 5. So if I had graphed these two lines, they would meet at the point 0, negative 5. All right, let's go to the next one. So in the next one, I want to either get the x's to both become 2, or I want the y's to both become 4. So I'm going to work on the x's becoming 2. So the top one's good to go. I'm just going to rewrite it. And I'm going to take the bottom one, I'm going to take everything times 2. So I get negative 2x plus 4y equals 6. And I'm not going to stop. Even though I see things are quickly becoming 0, I want to point out what that means. So I add the x's, I get 0. I add the y's, I get 0. And I add the numbers at the end, the constants, and I get 0. So when I'm done, I get 0 equals 0. So remember, same numbers when you're done mean the same line. So if I graph these two lines, they would be the same line, which means my answer is infinite solutions. All right, number 7. Number 7 is not quite ready to go. What I'm going to do is take the top one and move the 10 over. I'm going to do that by subtracting it. And here's the bottom one now. And now I'm going to work on either getting the x's to become 9 or the y's to become 15. And I'm going to get the x's to become 9. So the top one is the one I need to multiply. I need to multiply everything by 3. So I get 9x plus negative 15y equals negative 30. I don't need this one anymore, so I'm just going to draw a thin line through it. And I'm going to add up. And my x's add up to 0. My y's add up to 0. But my constant numbers at the end actually add up to negative 60. So when I'm done, I get 0 equals negative 60. And here, when I get different numbers, that means different lines. So this one is the one that means no solution. Different numbers, different lines, no solution. Same numbers, same lines, infinite solutions. All right, let's go to the word problem. So if you read it, it says you work at a grocery store. Your hourly wage is greater after 6 p.m. than it is during the day. One week you work 20 daytime hours and 20 evening hours and earn $280. Another week you work 30 daytime hours and 12 evening hours and earn a total of $276. So what's your daytime rate? What's your evening rate? They're telling you that they're two different amounts. So my first equation comes from the $280 day. I work 20 daytime hours and 20 evening hours, and when I'm done, I've made $280. And then in my second equation, that's the second day, I worked 30 daytime hours plus 12 evening hours, and when I was done, I had $276. So when I look at my numbers, I can either make um, my D's become 60, one has to be positive, one has to be negative, and actually the E's as well. The first number they have in common is 60, but some of you might think 120, so definitely go with the D's. So I will take the top one times negative 3. I'm going to go ahead and do that first. I could also take it times 3 as well, though. So 20D becomes negative 60D, 20E becomes negative 60E, and when I multiply with the 280, I get negative 840. And on the second equation, I'm going to take everything times just a positive 2. And when I do that, 30D becomes 60D, 12E becomes 24E, and my 276 becomes 552. So I'm going to add them up. My D's go away, which is what I wanted to have happen. My E's add up to negative 36. And when I'm done, my regular numbers add up to negative 288. So when I divide, I end up my evening rate is $8. And now to find my daytime rate, I'm just going to take the fact that E is 8 and put it into one of the equations. I'm just going to choose the one in red. So I will take the 30D equation plus 12E equation equals 276. And I'm going to take the fact that E is worth 8, put it into this term, which gives me 160. And now I'm going to subtract 160 to the other side, which gives me okay, have to back up a little bit. I did my math wrong. 12 times 8 is not 160. It is, sorry, 96. So now what I'm going to do is take the 276 and subtract 96. And when I do that, I get 180. And now when I'm done dividing, D ends up being 6. So my daytime rate is $6 and my evening rate is $8. And they told me that my evening rate would be more than my daytime rate, and it is. All right, I did point out in class that this 50 cents should be 33 cents, little typo there. So postcard stamps are 20 cents each, while letter stamps are 33 cents each. If you have 50 stamps worth $12.60, how many of each type do you have? So the number of stamps that I have is a total of 50 stamps, and I know that for each 20-cent stamp and for the 33-cent stamp, I have a total of $12.60. This is a good one to rearrange because you just have an x or just a plain y in the first equation, but I'm going to combine them. And what I'm going to do is make my x's here become both 0.20. The bottom one's good to go. It already is 0.20. So I'm going to take the top one times negative 0.20. So if I do that, I get negative 0.20x plus negative 0.20y, and then I get negative 10. So I'm going to draw a line through the top one, don't need it. And I'm going to add up my x's, go away. My y's add up to 13.13y. And my money at the end is 260, or my decimal, my constant. And when I'm done dividing by the 0.13, y ends up being 20. And y was the number of the 33-cent stamps. So y is going to be 20. And then I'm going to go back to the equation that I crossed out and figure out how many of the 20-cent stamps. So x plus 20 equals 50. Well, as soon as I subtract that 20, The number of the 20-cent stamps is worth 30 of them. All right, let's go to this problem. The sum of the digits of a two-digit number is 12. So if I have a two-digit number, essentially, so for example, 39, if I add 3 plus 9, I get 12. That's what that's saying. Um, the tens digit y is 2 less than the units digit or the ones place x. So when I do this, I am pretty specific. Y has to be the tens digit and x is the ones digit. So y plus x is 12. And it says the tens digit y is 2 less than the units digits or the ones place to find the other number. So when I look at which is more, when they said the tens digit y is less than the units x digit, um, the y digit as an individual number is less than the x digit. So if I simply take the y, I add 2, that'll give me what x is worth. And you could have done that through subtraction too as well. But what I'm going to do now is I'm going to take the fact that x is worth y plus 2, and I'm going to put it into this x. So I have y, and then for x, I'm going to put y plus 2, and then that's going to equal 12. So I'm going to clean up the left side, move that 2 over by subtracting, and when I'm done, I get y to be 5. So far, if y is the tens digit, my number is 50-something. So to figure out what the ones digit is, well, I'm just going to go back and take the fact that y is 5, put it into the second equation, and 5 plus 2 is going to be 7. Well, there's my ones digit, 57. So my number is 57. All right, for number 11, I'm actually going to go to a different page and set this one up. So let me copy it. And we do provide the answer, so that's to help you. All right, let's go ahead and get started. So I'm going to number them for the sake of 1, 2, 3. And when I look at my x's, I have a 3x and a negative 3x. That's done. I'm already going to go ahead and pair up the x's. I'm not going to bother looking at the y's or the z's. And I'm going to pair up 1 and 3, definitely. So here's 1. Here's 3. And now I need to pair up another 2. So I will either pair up 2 with 3 or 1 with 2. And I'm going to pair up 2 with 3 because when I look, I've got a positive 2x and a negative 2x. So that's just a little bit less work. So here come 2 and 3. And as I write these down, I do go through and add the opposite on everything. And I'm going to get rid of the x digit first in both of them. So the nice thing about the red equations, they're all ready to go. The x's will add up to 0, my y's add up to negative 3, my z's add up to a regular 3, and my constant numbers at the end add up to negative 12. When I look at the x's in the black equations, though, however, I'm not going to be able to do that. I have to change both of them, and I need to get both of these to become a 6. So I'm going to take the top one times 3. Go ahead and do that first. So I get 6x plus 9y plus 9z equals negative 6. And then I'm going to take the bottom one times 2. So when I do that, I get negative 6x plus negative 10y plus 2z equals negative 18. So I'm going to go ahead and add these up. So the x's go away. My y's, I get a negative y. My z's add up to 11. And my constant numbers at the end add up to negative 24. So now what I'm going to do is take these two equations, and I'm going to rewrite them, just so we have something to compare to. So here's the red equation. Here's the blue one. And I'm going to have to decide, do I want to get rid of the y's or the z's now? And I'm going to get rid of the y's because I can turn these both into 3. And since the top one already is a negative 3, I'm going to make the bottom one a positive 3. So that means I actually have to take everything times a negative 3 to do that. So negative 3 with that negative y is now positive 3y. I'm going to get negative 33z, and I'm going to get positive 72 when I take that times the negative 24. So I'm going to draw a line through it, and I'm going to add up my y's, add up to 0. And sorry, before I add, I just realized I made a mistake. Let me fix my green number. The 3 with the 11z is 33z, not negative 33z, not what I had. So my y's add up to 0, my regular numbers add up to a negative 30z, and then the constant numbers at the end add up to a positive 60. So when I'm done and divide, z is negative 2. And now what I'm going to do is take the fact that z is negative 2 and put it into one of the two circled equations that you guys see at the top. And I'm actually just going to put it into the blue one. One, because there's room, and two, it seems the easier one to work with. So putting it into this equation, and when I make z become negative 2, this term becomes negative 22. So now I'm going to add 22 to the other side, and I get negative 2. So that means positive y is 2. And now that I have y and I have z, I can pick one of my equations at the top, and I actually used the second equation, and I'm going to put my two numbers in there. So I'm going to take, moving down here, 2x, I don't know, plus 3y. This is the second equation. And I'm going to make this term become worth negative 6. And I'm going to take this term and make it become a positive 6. And then clean it up. The 6's add up to 0, so I get 2x equals negative 2. So when I'm done, x is negative 1. And that is the final problem for the second objective. Don't forget, the second day you take the test, so depending what hour this is, Wednesday or Thursday, that is the day your review is done. Okay? Have a great day. Bye, guys.